Hi, my name is Ryan McHenry, and I'm here today to present my findings on my capstone into the topic of web application development and finding a solution in a field that seems to be oversaturated in solutions. What we find is that when developing web applications, developers enter a field where, when looking to develop a web application, there are way too many solutions offered without any of them actually being proven as viable development solutions. And this is mainly a problem because it seems popular development solutions like full stack JavaScript solutions using just JavaScript as a language are saturating and kind of casting a shadow over the more traditionally relied upon web application development means. Some would question, is there really that many languages? And there's actually a lot more, and actually there's more that come out every day. So it's super important for us to identify a means for developers looking to answer the question as to which development language or collection of languages do I use to successfully develop a web application that's going to last longer than a year or two down the road when web browsers eventually change again. This problem basically leads to my thesis as to there are so many new development patterns emerging without being proven that it's eventually going to lead us into a cycle that doomed the software development field where no proven methods or foundational methods have been established. Therefore, multiple efforts of web application development will lead to failure. Essentially, in my literature review of my paper, we establish 4 major points. First, we look into the basic understanding of the web browser and its history and how it's developed. We examine why the foundation of the web browser is so weak. Thirdly, we examine web application infrastructure itself and kind of identify the 3 major parts of web application infrastructure so that we know how to, we know the languages that are needed to build those parts. And then finally, we look into the 4 major languages that ultimately result in well-developed web applications. Starting with the development of the web browser, we can see a pattern start to emerge about every 5 to 10 years. We see the web browser evolve. When it was first introduced, we saw a lot of text and static images. That was essentially what the web was. 5 or 10 years down the road, we start to see animated pages and plugins. Not as dynamic pages, but still starting to make web pages feel like they have life. Fast forward to now, where you can see rich internet applications. Here on the right is an animated GIF of Google Drive, which is a very popular web application. Now, what's caused the problems with web development and why there are so many solutions is basically the incompatibility with the web browser. What essentially has happened is companies have all started to develop their own web browser to create something known as the web browser wars. On the right is a little bit of a graph showing the percentage of uses of these browsers. Lately, in the last year or two, Opera's started to fall out of popularity, but it is still widely used out of the hundreds of browsers that you could choose. What this has done and why there are so many browsers is essentially fueled by the idea that companies want to create their own browser for business means. And a great example of this is Google developing their browser and using the Blink engine. On the right there, you can see every web rendering engine. But essentially, this leads to too many browsers with too many different behaviors and methods of rendering the web page, which essentially ends up with web developers having to solve a problem multiple times for it to be working for the web application. Understanding that is the major problem with the web browser is the incompatibility issues. We also must understand that web applications require 3 major parts to function. And essentially, we need the model layer as our layer to handle logic, the view layer to be the visual layer of our web application, and the controller to be the middleman to pass information back and forth and take commands from the user from their computer. And this essentially is how a web application works. And there are languages to help solve this, and we'll see this in the solution. But without these 3 major layers working together, a web application is not successful. So trying to skip one of these can actually be very detrimental. Moving on to languages are the 4 major points of actual web language development that need to be focused on when developing a web application. We see that abstraction is incredibly important since it allows us to develop major pieces without focusing on the details. This is especially important when we start to look into the concept of modularity, where we are developing individual components that can work independently. They're test and programmed independently. They're not reliant on other pieces. So that goes hand in hand with an abstraction. Model view support is essentially the idea that a web infrastructure or the technologies we're going to use is going to support the ability to plug in a structure to handle those 3 layers of web application development. Refactoring is simply the idea of being able to change code without it having sweeping changes throughout the whole site. So as we move on to our solutions, we have a basic understanding that web browsers are extremely incompatible due to their rendering engines. That there are 3 major parts we need to focus on with web applications, and there are 4 language properties that are important to us. And what this basically comes down to is looking at what is the most popular solution in the new and trendy development field versus what has been traditionally used, and that ends up being a full stack JavaScript solution using JavaScript as language, Angular as the MVC support structure, Node as the model layer, being able to pass information back and forth. But it's important to note that Node is not an actual backend language; it's a faux backend language, and MongoDB being the database that helps us, that gives us information to be persistent. And we can see that's actually the same here with the multi-language. As I said before, we've listed out what those languages do. And then on the multi-language solution, we see that PHP is the foundational language instead of JavaScript, Laravel being the framework, Apache being the routing and backend, and then MySQL being the database. And what we actually find with these solutions, and they actually, when comparing them, actually seem very similar. And it's easy to see why developers would think, one solution is better over the other. Each solution, due to their technologies, follows all of these rules, except in the concept of developing multiple page applications. And this is where, since Node, as we stated before, to help the backend is a faux language, it has a hard time basically pretending to be a browser. Since it's faux, it has to make up for the means of not actually being a backend language. So when web browsers start to have behavioral problems, Node has to sit there and try to compensate for those behavior problems because they're not built in. And this is essentially why with so many browsers, it's almost impossible to be able to handle things like SEO and simple things like the back button for the web browser. It's impossible to be able to make it work for all the different browsers since they all take different web rendering engines. So ultimately we find that the multi-page or the MAMP stack solution, which is just those technologies, the multi-language solution, is the safer means because it's not using a faux language, it's using a real backend language to create those behaviors. Ultimately, what I advise for people looking into this solution is to take out PHP and try Python instead. A lot of people swear by Python, and it's actually a very nice language. But I would also urge people to examine a little bit further into the failures of full stack JavaScript solutions and look into Twitter and why they decided to pull out of using full stack JavaScript solutions. Ultimately, we find it's safer to develop web application experience using the multi-language stack, mostly due to the having to force browser functionality. This doesn't mean you should really ignore the full stack JavaScript solution, but you should definitely keep continuing to look at it. But for the time being, I would say it's safer through the research that the multi-language stack solution is the best for web application development. And that basically concludes my research. And I'd just like to thank you for watching my presentation. Thank you very much.